it sometimes helps to understand Darwin's theory of natural selection if we put it in context of the time of what was going on in the scientific community at that time. What were people thinking? What was kind of the history of some of these ideas? And so that's what we're going to do today. So fair warning, this is a lot of old dead white guys, but we're going to focus on the key players that kind of put forth ideas that helped Darwin shape his idea of natural selection. So that's our main goal for today. We're going to take a look at the historical scientific context that shaped Darwin's theory of evolution in natural selection. Okay, so we're going to zoom way back in time, hop in our time machine, go back. We're going to hang out with Aristotle and Plato for a bit. Aristotle, in many ways, was kind of the very first biologist. He published an entire book just on talking about animals, right? He spent lots of time in lagoons looking at invertebrates, snails, things like that, talking about their organs and how they work. So Aristotle kind of decided that there was a system to how living things function, and there is a distinct scale, right? It's sometimes also scala natura, sometimes also translated as the chain of being. It's what's depicted here in a medieval text, where we have kind of minerals down here at the bottom, and then just above that are plants, and then we have the simple animals, and then we get more complex animals until finally we get to humans and then angels and then God, right? So he thought that there was a static chain of being with less complex organisms at the bottom, more complex organisms at the top, and all were created by God in their current state. And that this was an absolute, completely not changing. You can't move between the different scales. All organisms are just where they're at. Okay, so this was the predominant idea in how living organisms should be categorized at the time. And it was convenient because it was also supported by the Old Testament, that all beings were created in their current state. So the church was okay with it. So that's kind of the predominant thinking of how living organisms were classified for most of the time before Darwin came about. Then we get this cool guy, Carolus Linnaeus, or Carl Linn van Linn, before he Latinized his name. So a lot of scientific writings around this time period were done in Latin. Latin was considered the language of science, and a lot of scientists thought it was cool, or it made them seem more prestigious if they Latinized their name by adding us at the end of it. So that's his thing. So anyways, Carolus Linnaeus kind of took this idea of Aristotle's chain of being. He's like, yeah, that kind of makes sense. We could categorize all organisms. But he changed up this idea a little bit in the sense that he created what we still use today as our classification, our taxonomy system, right? And he went around and he grouped organisms into this nesting system that we know of as kingdom, phylum, order, class, genus, species, right? But he was using physical traits. And he thought that you could see, based on the physical traits, some sort of pattern to their creation, and that he created this taxonomy system to reflect that pattern of their creation, right? So the big difference here is that it's not a chain, it's a nesting system. Okay, we still use this today. Carolus Linnaeus is credited with identifying and naming many species whose names, for the most part, still stick around today. If you ever see like an L period at the end of somebody's name, or organism's name rather, that means that it was something that was named by Carl Linnaeus. So, nesting system as opposed to a simple chain, but he was still of the idea that these are static. There's no change in organisms, right? Their current form is the way they've always been. Then we kind of around the same time period, we get these three, probably more, I would say, they would still call themselves natural historians, but definitely more in the geology field. Cuvier is considered the father of paleontology. He was studying fossils in France. He was an advisor to Napoleon Bonaparte. And he observed, as he was looking at fossils, that those that are further down in Earth's crust, that are older, we would assume, are less similar in their form than to today's species than those that are closer to the top, right? So he recognized the importance of looking at the anatomy of a fossil to determine the shape and the function, the shape of an organism, right? He was also very early pioneer in the idea of comparative anatomy. But Cuvier was still the idea that life doesn't change, species might go extinct, and there's these catastrophic events that might wipe out a bunch of species and completely change the landscape, but species are static. They don't change throughout time. Okay. Contrast that to Hutton and Lyell. Hutton was one of the first geologists to really propose this idea that it's really slow, gradual changes that result in the geography and the layers that are formed on Earth's crust. Okay, so things like a river forming a canyon or a valley, or glaciers moving, right? So it's a really slow process. And then Lyell was like, well, that makes sense. And we can also assume that those same processes that cause those gradual changes are happening today, right? The Earth is still changing. So that kind of challenged the idea, if the process is slow, changes in Earth's crust are slow, the Earth is probably a little bit older than 6,000 years old. Okay, so that did not sit too well with the church at the time, but it makes sense when we're thinking about the history of life and how long evolution takes to happen, right? These were a lot of the predominant ideas that Charles Darwin was schooled in prior to his famous voyage on the Beagle. Okay, he was aware of the idea that there's fossils, that they are dissimilar to what we have today. He was aware that Linnaeus had been classifying organisms based on their similarities, their physical traits. And he was really interested in Hutton and Lyell's idea that these gradual changes in Earth's crust, the environment is changing, and that those changes are still taking place. So by the time Darwin came on the scene, the ideas that species change had been around. It had been proposed. But nobody had really come up with a mechanism for how species change or why species change that really made sense. So this idea had been proposed, species change throughout time, but nobody could really explain why or how. And that's where we get Lamarck. Jean-Baptiste Lamarck was really the first person to propose an idea as to why they change. And he came up with this idea of transferisme, which means basically that individuals can pass on their acquired traits to their offspring. And his famous example is a giraffe. Even though he'd never seen a giraffe in person, he was aware of them and he'd seen drawings of them. And he thought that the giraffes got the really long necks because an individual giraffe might stretch its neck a little bit to try and get the leaves that are up at the higher branches. And so throughout its lifetime, its neck is going to get a little bit longer. It will pass on that stretched out neck that it acquired throughout its lifetime to the next generation, which stretches that neck a little bit more, acquires a little bit longer neck by stretching it, and then passes that on to the next generation. Okay, so it's kind of like the idea that, let's say your mom's a bodybuilder. She's super buff, right? That you would inherit that bodybuilding physique. Okay, that's the idea of inherited acquired characteristics. And while we know now that that's not how it works, that's not how natural selection works and evolution works, Lamarck is credited with kind of predicting the whole field of what we call epigenetics, which is not something we're really going to cover in this class, but it's really interesting that there are some instances where acquired characteristics can be inherited through the markings on the DNA, but not the DNA itself. Okay, so that's a little preview for later. So this is kind of what Darwin was steeped in, a lot of these ideas, as to species change, there seems to be an order or a system to species, and the environment is changing. And we can look at older fossils to get a sense of what species may have looked like or what previous life forms could have looked like. And a lot of those life forms aren't around today. That led Darwin to that kind of laid the groundwork for Darwin to collect all of his observations and compile them in his Origin of Species.